Alright, so we're doing equations of circles today, and this is kind of an Algebra 2 pre-calc topic also. So this is something you're going to use moving forward. So let's, first of all, it says write an equation for the distance r, so the distance between these 2 points. So it's been a while since we've used the distance formula. We've been focused on the Pythagorean theorem a lot more lately. They're related to each other. So the distance formula is x minus x, in this case h, x minus squared plus y minus y squared. So there's the distance formula. So now if we want to solve for r squared, we could square both sides here. And then we usually flip that over. So we actually put x minus h squared plus y minus k squared equals r squared. Okay? So it says, what if hk is the origin down here? So what if that was here? Then h and k would both be 0. So you'd have x minus 0 squared, so that would be x squared. And then here you would have y minus 0, so that would be y squared. Okay. Now if we come back up here and talk about this, this is the equation of a circle. If we look at what we have there, the center is hk, and the radius is the square root of r. So those are some things that we want to remember. Now, if we look at this, we can compare it to some things that we had before. So we can think about y minus k equals m times x minus h. And so our point on the line was the opposite of x is h, and that's k. And then we would put the slope on that. Or if we think about parabolas, we had y minus k equals a times x minus h squared, and our vertex was the opposite of this, which is h, and the opposite of this, which is k. So these things are related to each other. That can help us. So moving on, it says write the standard equation of a circle with the given center and, so here's the center and there's the radius. So we start with x, so it would be x minus negative 5 squared plus y minus 0 squared equals, I would put 5 halves squared personally. I think it's easier to square that. So this is going to be x plus 5 squared plus y squared, and that's going to be 25 over 4. You don't have to do it as a fraction. I just think that that is easier. So now, this one, if we start it off, so here's the center. So x minus 4 squared plus y minus a negative 3, so I'm just going to put y plus 3 squared, equals r squared. But now what we can do is we can plug this point in to find r. So x is 2, so we have 2 minus 4 squared, and y is 1, so we have 1 plus 3 squared. So that's negative 2 squared, which is 4, and that's 4 squared, which is 16. Now, a lot of students really want to find r, but we're just writing the equation of the circle, so we're pretty much done now. So we can say that plus this, and remember, in the circle formula, the number over here is r squared. We have r squared as 20. So we don't actually need to solve for r unless they ask us what is the radius. So we could stop when we have r squared. Okay? So as you're taking these notes, if you have any questions, make sure you maybe put a question mark and ask in office hours or in person or wherever you are. Okay, so graphing a circle. So when we graph a circle, so these are highlighted. We usually put this on a test. That's going to be a little bit hard on the canvas, but we'll see. Maybe on Alex they have some. So first of all, we would like to identify the center. So the center is the opposite of this. So that's going to be positive 3, and the opposite of that is going to be negative 1. So 3, negative 1, that's right here. Now, the radius is the square root of that. So the square root of 4, which is 2. Okay, so the normal way we do that is we just take the radius and we count right, left, up, down, and we have that. Now, circles usually don't look very good when we try and draw them by hand, but one of the things I try to do is I try to draw 1/4 of the circle at a time, and I try to remember to just keep it kind of rounded. So rounded, rounded, round. Oh, too much on that one, but that's pretty good. This down here is a little bit too flat, but that's a pretty good looking circle, except for this part down here. 3/4 of a circle. Okay, in my opinion, anyway. Now we're going to go backwards. So we're going to take the equation or the graph, and we're going to write the equation that goes with it. So I'm going to kind of do the same thing I did over here, though. I'm going to identify the center. So the center, now you got to be careful here. So this is important. Anytime you have a graph, make sure you check the scale. Okay, anytime you have a graph, check the scale. Check the scale. This is going by 2's. So actually the center is 1, negative 3. 1, negative 3. So that's a little bit tricky if you're not paying attention. And the radius, okay, the radius is, so remember that's 1, and then those are both 2's, going by 2's, so that's 5. So the radius is actually 5. So now we can go x minus 1 squared plus y plus 3 squared equals r squared. All right. Here's where I got into trouble with that. I wonder if I can just move that while I'm talking here. Yeah, I can. That's pretty cool. All right. So there we go. Now, down here. This equation of a circle. 3 points are located as follows. Where are the 3 points located compared to the circle? Okay, so let's look at point A. So if we take point A and we plug it in there, we're going to have 5 minus 13 squared plus 6 minus 6 squared. So this is negative 8 squared. That's 64 plus 0. So that's 64. And if we compare that to this, 64 is greater than 9. So if that's greater than the radius squared, then that's going to be outside the circle, which hopefully makes sense. Outside of the circle. Okay. And if we look at point B and we plug that in, so that was 14. I kind of would rather do this. So 14 minus 13 is 1. And here, 8 minus 6 is 2. So that's 1 plus 4, so that's 5. And that's less than the radius squared, so that's going to be inside the circle. Okay? And finally, point C, gosh, I'm guessing it's probably on the circle, but let's see. So 16 minus, I guess I'll write it out again. 16 minus 13 squared plus, and again, 6 minus 6 squared. So that's 3 squared, that's 9. So 9 equals 9, so that's on the circle. Okay, so I think that's all pretty clear there. Okay, so now this is an important skill to have for Algebra 2, particularly, completing the square. So completing the square allows us to do several different things. In Algebra 1, you maybe would have done completing the square to solve quadratic equations, but let's see how this is going to work out here. So if we multiply those together, so it might be helpful to put x plus 11 times x plus 11 like that, and you can draw the box here if you want. So x plus 11 x, and you can't see that, move that down. Okay, and x plus 11 here. So you can multiply that out, but the pattern is you square the first thing, you multiply those together and double it, and you square the last thing. So hopefully you have that pattern down, but if not, and in Algebra 2 you're going to have to multiply more stuff, so these little boxes actually help when you have to multiply like a binomial times a trinomial or a trinomial times a trinomial. So trinomials with 3 terms, so if you're going to multiply this times itself, you could put 3 up there and then 3 here, you get 9 boxes. Okay, so if we look at some of these relationships here, if we factor this, so if we take half of this and square it, we get that. So if you go backwards from here, you take half of that, 11, and square it, you get 121. So it's kind of this, trying to understand the relationship between a perfect square trinomial. So here, same thing. So half of that would be -5, and squaring that, we would get 25. So we're really trying to focus on that relationship here. So if we move on to the next step, it would be, so we're trying to build up to this. Like, how does this stuff work? So if we're trying to make this a perfect square trinomial, we just want to follow that same pattern that we have there. So if you think about it, we go half of that would be 7. And if you want to write it like we had it here, it would be x plus 7 squared. And if we square that, that would be 49. So to make that a perfect square, we would have to add 49. And down here, very similarly, half of that would be 1. And then square that, that would be 1. So we would have to, I went kind of fast there. Again, always in your notes, you should be trying to pause and do stuff yourself when you think you know what's going on. Okay. So we want to convert these to standard form where we can see the center and the radius. So the first thing you want to do is organize your variables. So we're going to put x squared plus 4x together, and we're going to put y squared minus 6y together. And then we're also going to add the 23 to the other side. Okay? So that, I think, should be fairly clear first step there. Now, if we follow that same process where we're going to put x plus whatever squared, so what did we do? We took half of this and squared it, right? Now, if we want to organize that a little bit more in case it's more complex, we could say, what's the b term? So b is 4. And then we're going to take half of that, which will be 2. And then we're going to take half of b squared, which in this case would be 4. Okay? So whatever this middle thing is, that's what goes here. Following that pattern, take half of this, so that's 2. Okay? Now up here, we're going to add 4. So that's what we're trying to demonstrate with these examples up here to get to this point. So you take half of that and you square it, and you add that here. Now, we have an equation. We had something that was equal, and we just added 4 to this side. So that means we need to add 4 to this side also. Okay? Now here, we can do the same thing. So that's going to be y, this is going to be minus. Now you could write this out right here if you want to, but if you just look at it, half of that is 3, okay, squared. And if we square that, that's going to be 9. And again, we have an equation, and we added 9 to this side, so we need to add 9 to that side. So that's going to be 1336. And actually, that's it for that. Okay. Now, it wouldn't hurt to maybe mention that the center is at -2, 3, and the radius is the square root of 36, so that would be 6. They didn't specifically ask for that, but that's kind of what we're looking for when we do that. Okay, so here, let's do it again. Now, so pause and try it. We just showed you what to do, and try and do it without looking at that. So x squared plus, and then, so there's nothing else with that, so that's less work for us to do. We should be happy. And then this, and then add the 15 over there. Okay, so we have x squared plus y minus half of this, okay, and then square that, that's going to be plus 1. So plus 1 over here, so that's 16. Okay, and again, the center, now this time it's going to be 0 for x and 1 for y. The radius, square root of 16, 4. And again, they didn't ask for that, but that's okay. All right, so we have, this is from a math competition, and it says a rectangle with sides parallel to the coordinate axes is inscribed in this. We should all recognize this as a circle now, centered at the origin with a radius of 13. So I'm just going to put a rectangle in here. Try to be parallel to the sides there, roughly. So I used a compass to draw that circle. So something like that. And it's the radius is 13. So I know that that's 13. Now, it says the area is 240. Now, there's a couple different ways we could look at this. So one way we could look at this is, so this point right here is AB. So if that's AB, this distance is A, then that means this is also going to be A. And so this side is 2A, and this side is 2B. So we would have 2A times 2B equals 240, or A times B and divide by 4. A times B is 60. Now we can also look at this. If this is A and this is B, we could use Pythagorean theorem. So that would be A squared plus B squared equals C squared. Okay. Now, we could divide both sides by A or B here and then substitute in there and then solve that equation. That would be kind of cumbersome. That would be not very much fun. I don't even want to do that myself. So, another thing we could do is, because this area is nice right here, that means that maybe the numbers are nice. Okay? So, if we look at this, and we think about what would be some nice numbers, because they don't have to be nice numbers. I'm just saying it is possible. So if you think about a Pythagorean triple, we have a Pythagorean triple that has a 13 in it. Pythagorean triple. So what might come to mind is our 5, 12, 13. So if we try that, if we let A be 12 and B be 5, just because the way I drew this, we also could have drawn it, the rectangle more going this way. So if A is 5, that means that this across here would be 10. So, if we should use 12 for A. So if A is 12 and B is 5, then this side of the rectangle would be 24, and this side of the rectangle would be 10, and 24 times 10 is 240. Okay. So we could have 12, 5, or it could have been 5, 12, and then it says what is A plus B. So 5 plus 12 is 17. So the answer is 17. Now, if that didn't work out, if we did that and this answer wasn't 240, it was some other number, then we would have to solve. This is called a system of equations. And we could solve. So we said 240 was nice, so let's try some nice numbers instead of a system of equations. This was a system of equations. And we didn't need to do it that way. All right, last thing. Actually, we have some review as well, but I'm going to do that in a separate video because my last video didn't upload, so I'm going to do 2 separate videos. But derive the quadratic formula. So the way we do that is we're going to separate, so ax squared plus bx, and then over here we're going to put subtract the c to the side. So what we're doing is solving this for x, but we're going to use completing the square, and that's going to give us the quadratic formula. So as honors math students, that should be something that you're kind of aware of how to do. Okay, so the thing that I like to do next here is divide by a. So if we divide by a, we're going to have x squared plus b over ax equals negative c over a. Okay? And then we want to complete the square on this. So that's where we said, okay, identify b. So b is b over a. Okay, so half of b would be b over 2a. And if we square that, that's going to be b squared over 4a squared. Okay, so we can do the same thing we did up on those completing the square questions up there, and we can say, okay, this is going to be x plus, and we can take half of this, so that's going to be b over 2a, and square that. Okay, and then what do we put here? We square this, which is what I have over here. So that's b squared over 4a squared. Okay, but if we add that to this side, we need to add it to this side as well. So b squared over 4a squared. Okay. Now, we want to get a common denominator. We're subtracting fractions here, so I need to multiply this by 4a over 4a. So that's going to give us b squared minus 4ac, and that's over 4a squared. Now, let's take a time out for a second. It says derive the quadratic formula. We've been using the quadratic formula all year, so we should already know what the quadratic formula is. So I can come over here and we can write down what we're supposed to be trying to get. The opposite of b plus or minus the square root of b squared minus 4ac, all over 2a, right? So having that written down, I probably should have written that down the very first thing. That's where we're trying to go. We're trying to go from here to here. We already know the quadratic formula because we've used it almost every week this whole school year. Okay, so back to this. We're here, and I'm going to take the square root of both sides. Okay, so now we have the absolute value of x plus b over 2a, and that equals this, b squared minus 4ac. And what I could do there is I could take the square root of the denominator separately. I could split it up. So the square root of 4a squared is 2a. So I can leave the square root on the numerator because that's not simplifying nicely, and I can take the square root of this because it's a perfect square. Okay, so we're almost done. So then the next thing here is to take off the absolute value. And if we do that, we're going to get plus or minus over here, this thing. And then our last step is to subtract b over 2a from both sides. And then we already have a common denominator, so there you go. All right? And there'll be a second video posted underneath this one with the review page from before this lesson. All right, have a good day.